I found the cure to spider venom, and I cooked up a little potion this morning, and I'm feeling a lot better. It's pretty much just coffee. Let's get started. Today can be kind of tricky. Take a look here at our place value chart. Right, we have to take away 345,528 from 1 million, but in our 1 million, we just have this one dot in 1 million. The actual subtraction here isn't going to be very hard, but there's a couple steps leading up to that are kind of tricky. So make sure you're paying careful attention to how we work through subtracting across zeros. In order to do this, we're going to have to break apart this million. And not just once, but several times, because we have to get pieces all the way down into the ones place. Got to get pieces all the way down in the ones place. Let's go ahead and change our million here to the green color so that we can tell the difference between it and the black. And we are going to cross it out. We're going to break it up and send it over to the 100,000s. Now, how many 100,000s are in a million? Well, just like everything else, one place on the place value chart is worth 10. So if we're breaking up a million, we now have 10 100,000s. 8, 9, and 10. Unfortunately, though, we haven't done enough, right? Yeah, now we can subtract with our 100,000s, but we have to get all the way down to 0. So we're going to just keep doing this. We're going to break up one of these 100,000s, and it is going to become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10,000s. All right, so we brought this one over, and it became worth 10. I'm going to do the same thing with our 10,000s. How many am I leaving behind each time? I'm leaving behind 9. So each of these has become 9, 9, and now we're going to have another 9 as soon as we break this one up to move into the hundreds. 8, 9, 10. Cross that out. Now it's 9. And now we go into our hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see what I mean? It's just a lot of the same, but there's a lot of steps to it. So you have to make sure that you're not making an error here and throwing yourself off. Now I've got 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tens. And I'm going to break one of those up. And finally, we are down to our ones, where we have made 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can finally start subtracting. I can take away 2 of these. Oh, I'm sorry. I was going the opposite step. I can take away 8 of these. 1, 2, 3, 4, 5, 6, 7, 8, and see that I have 2 left. So that becomes a 2. I can take away 2 more of these. Be careful, though, because I've already marked this one out. So I can only mark out ones that haven't been used. 1, 2, 3, 4, 5, 6, 7. 7 are left. Same here. 1, 2, 3, 4, 5. I have 1, 2, 3, 4 left. 9 minus 5 is 4. 9 minus 5, same thing again, is going to be 4. 9 minus 4 is going to be 5. And 9 minus 3 is 6. I wind up with the answer 654,472. I wanted to show you that on the place value chart because although this is kind of tricky on the place value chart, it at least makes sense while being a little bit messy. In the standard algorithm here, it gets kind of messy and students tend to lose their place. So for the first 3 of these that you try, use your place value chart to help you. What we're going to do is cross out our 1, turn this into a 10. But now we have to keep borrowing, so I'm going to cross this out, turn it into a 9. This becomes a 10. Cross that out, this becomes a 9. This becomes a 10. And so on, just like we were doing before, all the way down until you get to this one here actually being a 10. And now our subtraction is the same. 10 minus 8 is 2, 9 minus 2 is 7, 9 minus 5 is 4, 9 minus 5 is 4, 9 minus 4 is 5, and 9 minus 3 is 6. You may be able to do this borrowing across the zeros up to the millions like this right away. But I want you to practice 3 problems with the place value chart anyway, just to make sure, just to get the same answer, and just to see how those numbers are moving and working. I really think those basic steps are important, so thanks for bearing with me here, and practicing those is really important. We have those in our brains so that we know how numbers work moving forwards into the harder skills that we'll be practicing in 4th grade. I'm going to drink the rest of my potion. Stay mathematical!